Okay, so let's look at this optimization problem. Let's read through it. It says a farmer plans to fence a rectangular pasture adjacent, which means next to, a river. The pasture must contain 245,000 square meters in order to provide enough grass for the herd. No fencing is needed along the river. What dimensions will require the least amount of fencing? So least means that we are going to minimize. So let's draw a picture because we need to get an equation in one variable. So here's our river. Draw some water in there. And our fence is going to have three sides against the river. And what we want to know is about the fencing on the outside, and we already know that we need our area to be 245,000 square meters. So let's look at our sides. What we know about our sides is we know that these sides will be the same, and this side will be different. So what we know is that our area is base times height, and the constraint that they gave us was 245,000 square meters. So our constraint is that 245,000 has to equal our base times height, which in this case is x times y. You can use any variable you want. We just chose x and y because it's easy to work with. So this is our constraint. So that is going to help us give them the answer they want. What we're doing is minimizing perimeter. So if we look, how we can get perimeter is if we have x plus y plus x. So we have two x's. So our perimeter is 2x plus y. That will be our total perimeter. This is what we want to minimize. So before we take the derivative, we want to make sure it's in one variable. So we go to our constraint to make that happen. So I think that I am going to solve for y to plug that in over there. So y is just 245,000 divided by x. So I'm going to plug it in up here so that I can have one variable. So this is 2x plus 245,000 over x. Now that it's in one variable, I will take my derivative. So the derivative of p is equal to 2x. The derivative is 2. And here, remember, this means that we have 245,000 times x to the negative 1. So that's how we can take the derivative of it. So when we take the derivative, we'll have negative 245,000 x to the negative 2. And how we will rewrite that in our equation is negative 245,000 divided by x squared. Now we need to find our critical numbers. We find our critical numbers by setting this equal to 0, 2 minus 245,000 over x squared. And right now this is difficult to solve for. So let's get that x squared out of the denominator. Multiply everything by x squared. 0 times x squared is 0. 2 times x squared is 2x squared. And the whole point of this, the x squareds will cancel here, and we'll just have minus 245,000. This we can solve for x. Add 245,000. Divide by 2. And we have x squared equals 122,500. Put that in your calculator. From there, we're going to take the square root. Now, usually when we take a square root, we get two answers, a positive and a negative. But remember, we're talking about measurements here, and we can't have negative measurements. So we can go ahead and throw out the positive because we know that will not reasonably be in our domain. That will not reasonably be an answer we can have. And the square root of 122,500 is 350. So that is one of our measurements. The other one is y. So we're going to take 350 and plug it in up here. Goodness, this computer. Okay. So we will have 245,000 divided by 350. And that will be, excuse me, and that will be 700. And our measurements for these are meters. So one of our dimensions, because it asked for the dimensions that minimize perimeter, so we are giving dimensions. One of them is 350 meters. And then our other one, so is by, that's not the eraser. One is 350 meters, the other is 700 meters. And those are two dimensions.